Welcome to the E6S Methods podcast with Jacob and Aaron, your weekly dose of tips and tricks to achieve excellent performance in your business and career. Join us as we explore deeper into the practical worlds of Lean, Six Sigma, project management, and design thinking. In this episode number 210, we continue our Process Pulse series with part 2, the 8 rules of statistical process control. If you're just tuning in for the first time, find all our back episodes on our podcast table of contents at e6s-methods.com. If you like this episode, be sure to click the like link in the show notes. It's easy. Just tap our logo, click, and you're done. Tap, click, done. Here we go. All right, the meat and potatoes, like really getting into it. We talked about what it looks like. We talked about the types. They all kind of follow, I shouldn't say all, but many of them follow many of these same rules that are applied. And we have 8 Western Electric rules, starting with Rule 1. Jacob, this one's probably your favorite. Take it away.
Yeah, but before I go any further, wasn't there 9 rules? We can do it at some point.
I'm going to have to look it up.
Yeah. But to answer your question, let's actually start with rule number 1, which is probably the most common, is, any data point that is more than 3 standard deviations away from the center line. That is the most common one that exists out there. And probably the simplest and easiest that everybody can remember.
And that's often most people stop at this one. And it is, and I think this is one that actually sets the definition for what will be a probability event for any of these other ones. So it's roughly 3 in 1,000, and that's kind of based off of going beyond 3 sigma in either direction.
Yeah.
There is some variation. Not all of them are exactly that, but I'd say roughly 3 in 1,000 is what is a trigger for a rare event.
I would agree. All right. So that was the first rule anyway. More than 3 standard deviations from the center. What's rule number 2, Aaron?
Number 2, 9 points in a row on one side of the center line.
Now, why is that important?
Well, seeing how your center line and your control charts are based off of historical data, this sort of shift from one side of the center line consistently would indicate that you've had a bit of a change. You've had a step or added a bias. And this could be your measurement system. This could be your process. This could be that you've decided to use a different tooling. So it's just a signal that says, hey, for the last 9 points, your process has been operating a bit differently than in its history.
Yep.
So check it out.
That's right. That kind of follows rule number 3, where now you have 6 points in a row. So 6 continuous data points that you're plotting are steadily increasing or decreasing. So in the previous case, it was 9 points on one side of the central line. Here, it doesn't matter if it was on or around the central line, but you have 6 points that are in a trend line or a straight line, either going up or down. And what it's trying to then show is that something is happening to your process, maybe due to environmental conditions, maybe due to wear and tear, maybe due to operator fatigue, not sure what, but something is happening that is causing the data points to show what that it's trending in one way or the other. And check it out. It's a warning sign.
Absolutely. Yeah, and I've seen this type of pattern where we've had dynamic systems. Say, for instance, if you are monitoring a cleaning tank and you have some sort of metric of cleanliness, and one part of cleaning means you're taking dirt off of parts and dropping it into the cleaning tank. So your measure of cleanliness will continue to degrade over time. So that's just a natural way of finding trends, and this type of rule could pick up on that.
Yep. What's rule number 4, Aaron?
Number 4, 14 points in a row, alternating up and down.
Ooh.
So this is basically your typical zigzag line, always up, always down, always up, always down, always up, always down, and constantly doing that. So by chance alone, this has a very low probability of happening if you see it 14 times in a row. So it is an indicator that we could have 2 sources or fudged data. And fudged data is interesting because they found that when we try to draw SPC charts, we actually draw them just like this because we have a hard time of actually drawing true randomness, usually we just end up going zigzag back and forth just like this. So that's one way that people think it could indicate fudged data, because the human brain doesn't like to I don't know, put too many in one direction. Something like that. It's kind of like taking a standardized test and you're just trying to make it designed down the test because you don't know any of the answers.
ABC.
Yeah. It could mean that you have two different machines that are plotted on the same one. So say if machine A is always higher, machine B is always lower, and that there's a bit of a bias between them, and that you're mixing data sources. So if, say, for instance, you're getting these things to final inspection and they were made on multiple machines and kind of mixed before there, the data are indicating that, there's probably two different things going on here.
Possible, yeah.
Yes, I should say possible, not probable, possible.
Yep.
All right, number 5. 2
out of the 3 points, which are on the same side, are more than 2 standard deviations away from the center line. So if you can imagine the center line and the control limits, well, we're not talking about control limits here. We're just talking about the center line, and let's say if we had to draw the zones of these are the points that are 1 standard deviation away, these are the points that are 2 standard deviation away, and these are the points that are 3 standard deviation away. When you have 2 out of the 3 in that zone of the same side of between 2 and 3 standard deviations, that's an area of concern, according to rule number 5.
Right. And it's basically, if you think about the normal curve, this is like just hanging out in the tail for a long time.
Yep.
It's just a low probability place to always be.
Mm-hmm.
So instead of 1 just beyond 3 sigma, if you have 2 hanging out within that 3 sigma, between 2 and 3 sigma, that's also low probability.
Correct.
And number 6, 4 out of 5 points on the same side, more than 1 sigma from the center line. May signify a process shift or a step change or something with by operator, procedure, or materials. It's kind of like the same thing as rule number 5, except we are further in toward the bulk of it, but we're hanging out too long on that one single side, essentially.
Yeah, you're getting biased towards one side, so it's almost like the previous case, right, where you had, or rule number 2, where you had 9 points in a row on one side of the center line. It's kind of like what you're saying. You're within this particular zone, so kind of keep an eye on that.
Right. Yeah, and it all is measured based on how far away you are from this 50 percentile point, right? If you don't cross that 50 percentile point enough times, and you hang out too far on one side, it says this is a little odd. You're not really behaving randomly.
Correct. Rule number 7: 15 points in a row within 1 sigma of the center line.
This is awful. I hate processes that do this.
Well, this is where, in my opinion, somebody's really cooking the data. Or this is where this can happen a lot, especially when your measurement system is being rounded up or your data points are being rounded up significantly, that you're not able to distinguish the differentiation between the thing. Those are some of the cases where I've seen this happen a lot.
I feel like I baited you there, because I actually love seeing this, because this is exactly what would happen if your data, also, if I ignore all the bad stuff you said, those things are true. But if I also look at the bright side, this is also what should happen with your projects, where your process control has gotten so much better that you have very little variation relative to historical standard deviations, and it has been tightened. So this can be an indication that something good happened. You need to go find out what it was and see if you can make that happen more often. And another action that would be to be taken is to redefine your control limits, because they may no longer be applicable.
That's true. Good point.
You are listening to E6S Methods Podcast, brought to you by E6S Industries. Join us on our website at www.e6s-methods.com. Journey through success.
Are you applying for professional certification in your field? You'll be happy to learn that all this time you've been streaming Jacob and me into your ears, you've also been earning continuing education units, or CEUs, which can be applied toward most professional certifications. You can do your research, all the math, and figure out which episodes are applicable for which discipline, or you can save yourself the time and hassle and just order a CEU report from us. All you need to do is provide us with which episodes you've listened to, and we'll provide you with a portfolio including details about each episode and a certificate of recognition with a CEU breakdown by competency, including leadership, tactics and tools, strategy deployment, and principles and philosophies. So if you have certification on the mind, start here and save some time. Just go to e6s-methods.com/CEU to order yours.
And what's the last rule? Saving the best for the last one.
All right. Rule number 8, 8 points in a row, more than one sigma from the center line, but it could be on any side. It could still cross the center line, but if it's doing just these large swings into the 2 sigma zone and just crossing over, it could be a lot like one of the other rules, that it could be coming from multiple sources. Could be erratic behavior, but this is the one I see more often, is this over control. And over control is caused by somebody looks at a process randomness and say, oh, that's a little too high, let me tweak it down. And say, oh, that's a lot further down than I expected, let me tweak it up. And they end up over controlling the process, meaning they're responding to what should be randomness, where they should actually just leave it alone. My belief is set it and forget it and let the process work its magic. And I've had operators that would actually reduce the overall yields on the machine because they just keep tweaking the dial because they're trying to manually tune in the process.
Make it
and they're
perfect.
just responding to noise. Yeah.
Get perfect.
All right. What are the typical errors for doing SPC?
Well, typical errors when you're doing SPC is that you're probably not doing it in real time, where somebody reported it, kind of like what you mentioned earlier, right? We have all the data. We're not necessarily plotting it, but customer's coming. It's the end of the month. Let's pretty up that report so we can send it to somebody to show them what we've been doing. And you're plotting it after that, and then you're saying, we should have checked on this earlier. We didn't necessarily do that, so that's the big problem.
Yeah, make that disappear. How can we brush that row out?
Exactly.
Yeah, and this is one of my pet peeves, this next one, and I'm definitely a purist when it comes to I shouldn't call myself a purist because I don't actually practice this, but my pure belief is how things should be is that the mistakes that people make is leaving it up to the engineer or the intern, meaning they don't actually delegate this down to the shop floor of the people who are doing the work. So I believe that this actually should be within the engineer helps set it up, but they need to set it up in such a way that it can be real time and that the operators are monitoring it, the health of their own processes, rather than engineering oversight coming in, doing spot checks. And the way operations work in too many companies is the operators just are told, and they fit in that culture, just stand back. I'm not going to do anything. I don't want to get in trouble. I'm not going to do anything until the engineer gets here. And that's kind of a mentality that I would like to see change in a lot of our operations, because having the operators really own their process and the ability to stop a process when necessary is what makes for a efficient and effective manufacturing and improvement culture, and frankly, just a better day at work.
Yeah. And
there's my tirade.
I mean, you bucketed engineers and interns. I would probably add QC to that group as well. Many a times it's a QC department or somebody from quality control who's coming and checking that to see is this part in spec or not in spec. And, when that could have been delegated to and maybe not the entire piece, but some components of it, some attributes of it could be easily spot checked by the operator himself or herself to make sure that it is in line and, it's a higher probability of it passing the test it needs to pass.
Right. Using lack of software or technology as an excuse to not do it at all.
Yeah, I don't have Minitab, Aaron. How can I get these SPC charts going?
Yeah,
seriously.
We don't have that.
We don't have the license. And we don't want to give everybody the license for that.
And our operators can't use Excel. Well, first of all, you can do it in Excel. It's a little bit harder, but honestly, all of these things were invented in the 1920s. Guess what didn't exist in the 1920s?
Computers.
Yes. Well, maybe somewhere they did, but not like we have them now.
Correct.
All of these were made to be done on large poster charts hung on the wall and to be done by hand. I have, one of the old books that shows exactly how to do it by hand. It's actually meant to be done by hand and intended to be done by the operators themselves. So that's not an excuse.
All right. Another one would, and again, we alluded to this earlier, using the wrong chart for the wrong purpose.
Right.
It is a typical error. I wouldn't say typical error, but it is an easy way to make an error, especially for somebody who's trying it out for the first time or not really sure why. Somebody just came and told me I need to do an SPC chart. This one looks like a good enough option. Let me just do this and move on with life.
Yeah, and I see this happens more often because they're choosing from a large menu within software, and they're like, "Oh, is it this one? Let me try it." And then I'll get a call for help. So, I can't get the P chart to work on this. Well, that's because you should be using an XBAR chart kind of thing.
Yeah, you're having continuous data, buddy.
And then not updating the control limits after a significant process change. So when you do something intentionally or make a significant change, you are supposed to go ahead and remeasure, create a new baseline, and make sure that everything follows suit. All right, so that's kind of it. What do you think about a recap?
Sure. I mean, again, like we pointed out earlier, it's not something new. SPC was invented by, I believe he's a doctor, Dr. Walter Short, who was working for Bell Labs in the 1920s. What the expectation is, it helps the teams or the operators or the individuals monitor the health of the process and keep an eye on any unanticipated or any sort of shifts or trends that's going on, which can alert you, take the necessary actions to not impact your process or your problem. An example, like an EKG reading, you know that something's going to fail if your EKG's variation is really, really high. So sooner than later, you're going to have some heart trouble. So get acting on it. We kind of covered the different types of SPC charts. The most basic ones were the IMR, XBAR, PNU. We talked about some of the others. Again, depending on what sort of data you have and what you're trying to do, you want to make sure you're picking the right one. We covered the 8 rules, which we still have to clarify how the history on that was, but I'm pretty sure Aaron did the research, so it is correct, on what should be the things you look for as you plot these SPC charts. What are some of the warning flags that you can get that will make you want to dig into some of these data points? And then we talked about the most common errors while you're doing an SPC. Most important that you probably missed or didn't cover is the fact that you don't do SPC, or you're not necessarily doing it in real time and you're just trying to please somebody by creating a nice fancy chart at the end of the day. And that wraps up the recap, unless you would add something else.
Just if you're only doing it because your customers are telling you they want you to do it, you're missing out on a great opportunity to actually take control of your processes. And I'll leave it at that.
Excellent.
All right. Anything else, Jacob?
No, that's it. Thanks, Aaron.
Awesome. Thank you very much. And thanks, everyone, for listening.
All right. Have a good one.
Thanks for listening to episode 210 of the E6S Methods podcast. Don't forget to click like or dislike for this episode in the show notes. Tap click done. If you have a question, comment, or advice, leave a note in the comments section or contact us directly. Feel free to email me, Aaron, Aaron, at e6s-methods.com or on our website. We reply to all messages. If you heard something you like, then share us with a friend or leave a review. Didn't like what you heard? Join our LinkedIn group and tell us why. Don't forget you can find notes and graphics for all shows and more at www.e6s-methods.com. Journey through success. If you're not climbing up, you're falling down.